Haumea, the fifth recognized dwarf planet in our solar system, follows a fascinating path from its discovery to receiving its official name. This elongated celestial body, orbiting beyond Neptune in the Kuiper Belt, represents a unique chapter in modern planetary science, not only for its unusual physical characteristics, but also for the controversy surrounding its discovery and subsequent naming. The story of how Haumea received its name involves competing research teams, accusations of scientific impropriety, cultural considerations, and the formal processes of the International Astronomical Union. The story of Haumea's naming begins with its discovery, which became the subject of controversy between two astronomical teams. A team led by Mike Brown of the California Institute of Technology, including David Rabinowitz of Yale University and Chad Trujillo of Gemini Observatory in Hawaii, discovered the object on December 28, 2004, while reviewing images they had taken on May 6, 2004. The Caltech team initially used the informal nickname Santa among themselves, a playful reference to the timing of their discovery just after Christmas. Meanwhile, a separate team led by José Luis Ortiz Moreno at the Instituto de Astrofísica de Andalucía at Sierra Nevada Observatory in Spain claimed to have found the same object in images taken between March 7 to 10, 2003. The competing discovery claims would later prove crucial in determining who would have the honor of naming this significant celestial body. The formal announcement sequence began on July 20, 2005, when the Caltech team published an online abstract of a report intended to announce their discovery at an upcoming September 2005 conference. Just a week later, on July 27, 2005, Ortiz and his team emailed the Minor Planet Center with their own discovery announcement. This timing would later raise suspicions and lead to controversy. Following standard astronomical naming conventions, the object was initially given the provisional designation 2003 EL61 on July 29, 2005, based on the year in the Spanish team's discovery images. This alphanumeric code follows the International Astronomical Union's systematic naming convention for newly discovered celestial objects, where the year indicates when the discovery images were taken, followed by a code indicating the half-month of discovery and a sequential number. The object's significance was further recognized on September 7, 2006, when it received its permanent minor planet number, becoming 136108, 2003 EL61. This numbering indicated that it was the 136,108th minor planet to receive a permanent designation, signifying the growing catalog of known objects in our solar system. What might have been a straightforward scientific discovery soon became complicated by serious allegations. While Mike Brown initially conceded discovery credit to the Spanish team led by Ortiz, his perspective changed dramatically when he learned that the Spanish observatory had accessed his team's observation logs the day before their discovery announcement. These logs contained enough information to allow the Ortiz team to locate the object in their 2003 images. Further raising suspicions, these logs were accessed again, just before Ortiz scheduled telescope time to obtain confirmation images for a second announcement to the Minor Planet Center on July 29th. In scientific discovery, transparency about methods and information sources is considered essential ethical practice, and the Spanish team had not disclosed their access to the Caltech logs in their announcement. When confronted with this evidence, Ortiz admitted accessing the Caltech observation logs but denied any wrongdoing, stating he was merely verifying whether they had discovered a new object. This justification did little to resolve the ethical questions raised by Brown and others in the astronomical community, creating a cloud of controversy over what should have been a celebrated scientific discovery. The International Astronomical Union, as the world's authoritative body for astronomical naming, has established protocols for attributing discovery and naming rights. According to these protocols, discovery credit for a minor planet typically goes to whoever first submits a report to the Minor Planet Center with sufficient positional data for a reliable determination of its orbit. The credited discoverer traditionally receives priority in choosing a name for the newly discovered object. In this case, the Spanish team was the first to file a claim for discovery to the Minor Planet Center in July 2005. According to strict interpretation of IAU protocol, this would normally grant them naming priority. However, the unusual circumstances surrounding the discovery claims complicated the process significantly. The name Haumea comes from Hawaiian mythology, where she is the goddess of fertility and childbirth. This divine figure holds significant importance in Hawaiian cultural traditions as the matron goddess of the island of Hawaii. In mythology, Haumea is noted for having many children who sprang from different parts of her body, a characteristic that would prove metaphorically appropriate for the celestial object. In Hawaiian traditions, Haumea is also identified with Papa, the goddess of the earth and wife of Wakea. This association seemed particularly fitting at the time of naming, because Haumea was thought to be composed almost entirely of solid rock, unlike other Kuiper Belt objects that typically have a thick ice mantle over a small rocky core. This understanding of Haumea's composition would later evolve with further study, but the mythological resonance remained powerful. The Caltech team, in proposing the name Haumea, sought to pay homage to the place where the satellites were discovered, acknowledging the Mauna Kea Observatory in Hawaii, where much of their research was conducted. Beyond this geographical connection, the name proved remarkably appropriate for several scientific reasons. First, as the goddess of childbirth with many children who emerged from different parts of her body, Haumea's mythological narrative parallels the scientific understanding that the dwarf planet's 2 moons and possibly other Kuiper Belt objects may have formed when fragments broke off from the main body during an ancient collision. This family of celestial objects mirrors the goddess's mythological family. Second, Haumea's association with stone in Hawaiian mythology corresponded with early theories about the dwarf planet's composition, which was believed to be primarily rocky rather than icy. Though later research would revise this understanding, the initial perceived connection added another layer of appropriateness to the name. According to IAU guidelines established at the time, classical Kuiper Belt objects were to be given names of mythological beings associated with creation. Following these guidelines, in September 2006, the Caltech team formally submitted names from Hawaiian mythology to the IAU for both the main body and its moons. Meanwhile, the Spanish team led by Ortiz had proposed a different name, Aresina, after the ancient Iberian goddess of spring. However, this proposal faced a technical obstacle. The IAU had reserved names of chthonic deities, underworld gods, for stably resonant trans-Neptunian objects such as Plutinos that resonate 3.2 with Neptune. Since Haumea was in an intermittent 712 resonance with Neptune, it did not qualify for a chthonic deity name under the IAU's classification system. The final resolution came on September 17, 2008, when the IAU officially announced that the object had been named Haumea. Interestingly, this announcement came from a dual committee established specifically for bodies expected to be dwarf planets, rather than through the standard minor planet naming process. In a nuanced decision that attempted to acknowledge both teams, the IAU listed the location of discovery as the Sierra Nevada Observatory of the Spanish team, while accepting the name Haumea proposed by the Caltech team. This compromise solution reflected the complexity of the situation and the IAU's attempt to navigate the competing claims while adhering to its naming guidelines. The announcement also formally classified Haumea as the 5th dwarf planet in our solar system and the 4th Plutoid, dwarf planets beyond Neptune, elevating its astronomical significance. The naming of Haumea extended to its satellites, maintaining the Hawaiian mythological theme. In 2005, 2 moons of Haumea were discovered, and they were subsequently named after daughters of the goddess Haumea. The larger moon was named Hi'iaka, after the goddess of the island of Hawaii and of the hula dance. This moon has an orbital period of approximately 49 days around Haumea and a mass about 0.5% that of Haumea. Like its parent body, Hi'iaka has a relatively fast rotational period of about 9.8 hours. The name Hi'iaka carries significant cultural meaning in Hawaiian mythology. As Haumea's daughter, she represents the connection between the divine maternal figure and the physical island of Hawaii itself. This naming choice strengthened the thematic connection between the celestial body and Hawaiian cultural traditions, while also acknowledging the location of the Mauna Kea Observatory, where much of the research on Haumea was conducted. The smaller moon of Haumea received the name Namaka, after a water spirit in Hawaiian mythology, who is another daughter of Haumea. Namaka has an orbital period of approximately 18 days around Haumea and a mass about 0.05% that of the dwarf planet. Both moons, like their parent body, are covered in water ice, making the water spirit association particularly fitting for Namaka. The naming of both moons after daughters of Haumea not only maintains mythological consistency, but also scientifically aligns with the theory that these satellites formed from material ejected from Haumea during a collision. This origin story parallels the mythological narrative of Haumea's children emerging from different parts of her body, creating a poetic connection between ancient cultural stories and modern astronomical understanding. Beyond its official name, Haumea has also been assigned a symbolic representation. A planetary symbol for Haumea has been included in the Unicode standard at position U+1F77b. While planetary symbols are no longer widely used in professional astronomy, they maintain significance in cultural and historical contexts and continue to be used by astrologers and occasionally by NASA. The symbol for Haumea was designed by Dennis Moskowitz, a software engineer in Massachusetts. In creating the symbol, Moskowitz combined and simplified Hawaiian petroglyphs representing woman and childbirth, reflecting the mythological identity of Haumea as the goddess of fertility and childbirth. This thoughtful design connects the modern scientific designation with ancient Hawaiian cultural representations, bridging thousands of years of human understanding. The effort to document and standardize pronunciation reflects a growing awareness in the astronomical community about the importance of respecting the cultural origins of celestial names. By drawing from Hawaiian mythology for both Haumea and its moons, the astronomical community acknowledged the significant contributions of Hawaiian observatories to modern astronomy, while also paying respect to the indigenous culture of the islands where some of the most powerful telescopes are located. This cultural consideration represents an evolution in how the scientific community approaches the naming of significant celestial discoveries. Tracing the chronological progression of Haumea's discovery and naming provides insight into the often lengthy process of astronomical identification and designation. The earliest known images containing Haumea were actually taken on March 22, 1955, though the object wasn't identified in these images until much later. These pre-covery images were discovered during subsequent research, extending the observation arc of Haumea to over 6 decades. The more relevant timeline for naming begins with the Spanish team's images from March 7 of 10, 2003, followed by the Caltech team's images from May 6, 2004, and their recognition of the object on December 28, 2004. The competing announcements in July 2005 led to the provisional designation 2003 EL61 on July 29, 2005. The object received its permanent minor planet number as 1361-8. 2003 EL61 on September 7, 2006. The Caltech team submitted their naming proposal from Hawaiian mythology in September 2006, and after nearly 2 years of consideration, the IAU officially announced the name Haumea on September 17, 2008. This announcement coincided with Haumea's formal classification as a dwarf planet and Plutoid. The naming of Haumea coincided with a period of significant evolution in how astronomers classified objects in the outer solar system. Following the controversial reclassification of Pluto from planet to dwarf planet in 2006, the IAU was establishing new categories and naming conventions for these distant objects. Haumea became part of this new taxonomic framework as the 5th officially recognized dwarf planet and the 4th classified as a Plutoid. This classification context is important for understanding the attention given to Haumea's naming process, as it was one of the first objects to receive a name under the new dwarf planet designation system. The dual committee established by the IAU specifically for bodies expected to be dwarf planets reflected the special status given to these objects in the revised solar system taxonomy. Haumea's physical characteristics make it a truly unusual object in our solar system, and some of these features influence the appropriateness of its name. Unlike most dwarf planets, which tend to be roughly spherical, Haumea has a distinctly elongated shape. Its dimensions are approximately 2,322 x 1,704 x 1,138 kilometers, giving it a shape more like a rugby ball than a sphere. This elongation is believed to result from Haumea's remarkably fast rotation period of just 3.92 hours, which causes the object to stretch out along its equator. This rapid spin makes Haumea the fastest rotating large body in the solar system. The unusually dynamic nature of this dwarf planet resonates with the active, life-giving aspects of the goddess Haumea in Hawaiian mythology. While initially thought to be primarily rocky, later research revealed that Haumea likely has a thin water ice crust covering a rocky interior. This makes it different from most Kuiper Belt objects, which typically have a more equal mixture of ice and rock. Haumea has a relatively high density of 1.885 grams per cubic centimeter, making it one of the densest Kuiper Belt objects known. Haumea also features a notable surface characteristic called the dark red spot, which may be an impact crater that has revealed the dwarf planet's interior. This wound in the surface that exposes the interior could be poetically connected to the mythological Haumea, whose children emerged from different parts of her body. One of the most fascinating aspects of Haumea is that it appears to be the largest member of a collisional family of objects in the Kuiper Belt. About 10 other Kuiper Belt objects have been identified with orbits, rotational periods, and icy surfaces similar to Haumea's. This family of objects is thought to have formed when a large object collided with Haumea in the distant past, breaking off fragments that became separate celestial bodies. This collisional family concept perfectly mirrors the mythological Haumea's role as a mother goddess with many children. The scientific understanding that these objects literally broke off from the main body of Haumea creates a direct parallel to the Hawaiian mythological narrative of Haumea's children emerging from different parts of her body. This remarkable coincidence between myth and astronomical reality adds an extra layer of appropriateness to the name. While Haumea's 2 known moons have already been named after daughters of the goddess, the existence of a broader Haumea family in the Kuiper Belt presents opportunities for consistent mythological naming of additional objects. Should any of these related objects become significant enough to warrant formal names, the Hawaiian mythological theme established with Haumea could potentially be extended. This naming legacy represents one of the long-term impacts of the decision to name the dwarf planet after a Hawaiian goddess. It has established a cultural framework that may influence the naming of outer solar system objects for decades to come, especially those found to be dynamically related to Haumea itself. The naming of Haumea represents a fascinating intersection of astronomical discovery, scientific ethics, cultural respect, and institutional process. From competing discovery claims and controversy to the final selection of a culturally significant Hawaiian name, the journey of Haumea's naming reflects the complex human dimensions behind scientific nomenclature. The name Haumea has proven remarkably appropriate for this unusual dwarf planet. As a goddess of fertility and childbirth, whose children emerged from different parts of her body, Haumea provides a perfect mythological parallel to a rapidly rotating, elongated celestial body that appears to have spawned a family of smaller objects through collision. The Hawaiian cultural connection also acknowledges the significant role of Hawaiian observatories in modern astronomy. Beyond the name itself, the story of Haumea's discovery and naming offers valuable insights into how the scientific community manages competing claims, applies naming conventions, and increasingly recognizes the importance of cultural context in the naming of significant celestial objects. As our knowledge of the outer solar system continues to expand, the case of Haumea stands as an important precedent in how we assign meaning to the newly discovered worlds that orbit our sun.